want to thank all of you for attending. I know you're going to learn a lot. And if you have your questions, mark them down or put them in the chat, or you can verbalize them near the end. Give her time to give her talk. And we have today our third Women in Science presenters, Karina Philippovich. And she's a relatively recent graduate, but she is an engineer now, and she's going to share with us her story. Okay, so Karina, and if you want to introduce anybody, Karina, you may, please.
Okay, yes, hello everybody. Thank you for having me here today. Thank you to Scholars Academy. Thank you, Dr. Parker, and fellow future graduates. I'm going to share my screen now. Oops. This is the first time doing it through Google. Okay, so Dr. Parker, give me a thumbs up if you can see this.
No, not yet. It says it started screen sharing, but we're not seeing it yet.
Okay. Can you see it now?
No, not yet. Can you pull it to your desktop and maybe do it that way?
Thank you.
Nothing yet. There's the issue with the technology. It's always something, you know. Ah, there we go. You're good to go.
Okay.
Great.
Okay. So my name is Karina Philippovich, and I work as a bridge engineer at Consor Engineers. Like Dr. Parker mentioned, I graduated from UHD in 2019. And a lot of the work I do is brought by TxDOT, which is the Texas Department of Transportation. Each state has its own Department of Transportation, and my company works as a consultant for those projects, which is like roadway, bridges, drainage design, things like that. And here, I'm going to show you a little bit of this roadmap about my journey. Right, life is never taken in steps. You kind of have this wave of things coming at you and things going on in your life. And I started off at Lone Star College. There, I got my drafting degree, my architectural drafting degree, and obviously UHD, Gators. Dr. Parker hates it when I do that, so I'm gonna I came up with that, so if anyone sees you doing that, that was me. I interned at the Port of Houston during my time at UHD, and to the right you'll see that I work at Consor now, and I'm pretty involved with the Society of Women Engineers now. And I want to show you guys a little bit of the work I was doing while I was at Lone Star. These are 3D models that are rendered, and a lot of the things I was doing was learning building design, drafting, learning about construction details and plans preparation for construction for like houses, and you see things like this, like gas stations. And my goal was to eventually become an architect. And this was just something I was obsessed with, and I loved doing these kinds of things. These models that you see here are what we call BIM models. BIM stands for Building Information Models. They're actually the future of construction. The reason why they are the future is because these models allow you to create ahead of time what the structure or building or whatever you're trying to construct is ahead of time in your computer. And by doing that, you can catch mistakes ahead of time. So for example, in a building, if you are modeling the building, you're creating this 3D model, you can also put in that model the ductwork, any kind of plumbing system that you need, what's going to go into the walls. And you can do clash detection with those BIM models. And that's been really useful for architects and for contractors. When I say contractors, that's what we refer to people who actually construct and build whatever it is that we need to build. It's a very important job. So contractors out in the field know ahead of time what to look out for, and we can find those mistakes ahead of time. Now, when it comes to civil engineering, it's similar, but these pipes are in the ground, and you can create models of roads and bridges, and which I'll show you a little bit later. So it's the future. You can see here, these are not the most impressive things you can do with this software, but at the time, it was really eye-opening to me and so much fun. I love doing these things. I love making models. I love using computer programs. I love the challenge it brings. So I thought I wanted to be an architect, right? I was preparing myself to apply to the schools of architecture and the University of Houston main campus and Prairie View A&M. They have a beautiful College of Architecture there. And so these were the options that I was weighing at that point in my life. And I was finishing my classes at Lone Star, and suddenly I came across this class that was required for me to graduate. And it's called statics. This is considered an engineering course, or at least an introductory engineering course. I had never taken anything like this in my life. I wasn't sure why I had to take it. I never heard of it. But to give you some information about it, it's considered, you could call it the study of bodies in equilibrium, or I say it's the study of objects that are not in motion. This image here might scare you, which is how I felt when I started taking this class. It's overwhelming. There are things going on everywhere. I don't understand the calculations. I actually am not very strong in math to begin with, and I never had confidence in myself with things like this. But the professor teaching that class, that one summer I had to take it, was one of the best teachers I've ever had in my life. He really held my hand through this class. It was like a 5-person class. He would sit down next to me at the desk and say, okay, what are you confused about? Let's do this right now together. We'll go through these problems together. And because of this class and because of that teacher, it's the reason why I'm standing here talking to you today. If I didn't have an experience like that so early on, I wouldn't have continued to study engineering. Then I went to UHD, and this is the only picture I have of that time. I'm just kidding, but I went on to study structural analysis and design at UHD. Thank you, Fatma. I love your little things. Also, if anyone can send me fun messages in the chat, like, please do. It helps me. So I was, after taking that class at Lone Star, I I had a newfound confidence in myself. I decided that the drafting classes I took there, they were very easy to me. I kind of flew through them and could just fall asleep in class and still do okay. The challenge just wasn't there for me. Even though I loved it, I knew that I wasn't sure if becoming an architect would be fulfilling enough in my life. And I wanted to figure out what this structural engineering business was all about, and if taking that class leading me to UHD was a good idea or not. So this is what every night kind of looked like: doing homework, learning about reinforced concrete beam design with my cat. So what do transportation engineers do? That's what you could call what I do. I'm a transportation engineer, but I'm also a structural engineer, which falls under civil engineering. I know it's very confusing, but here's an example of an engineer in her natural environment, just so you can see what that looks like here in my house, working from home. But I'll tell you what they do. They wake up every morning and they drink a cup of coffee, sometimes two. And if it's not enough, then they go to the Keurig and they press the biggest button that you can on the Keurig, and sometimes press the strong option on the Keurig. But besides that, we design roads and bridges in order to let society function and in order to support the economy, right? If you think about it, if you don't have a road near your house, connected to your house, you won't be able to get to school. You won't be able to get to work. You can't make money. These are things that might seem very obvious, but when you really start thinking about it, there are engineers in our lives that do all of these things for us that we don't even notice, right? It's like you're walking down a sidewalk. Well, an engineer spent a really long time figuring out how these sidewalks are going to connect in your neighborhood and connect in a way that water doesn't puddle on your sidewalks. I'm so sorry if water puddles in your sidewalks. That's not supposed to happen. A good engineer would make sure that didn't happen. But transportation engineers essentially do those things: is focus on roads, bridges, and making sure the drainage that surrounds them doesn't affect the surrounding environment. And that is a very basic description of what we do. And actually, today I wanted to teach all of you a little bit about engineering. It doesn't matter what your major is. It doesn't matter if you're a dog or a cat or a baby or a human. You're going to walk away today with knowing just a little bit more about what I do. So I hope you're all excited and ready for that. I'm trying to look at the chat. Maybe, okay, it sounds exciting. Good, good. Okay. So, whoa, crazy picture, right? No, I'm going to break it down for you right now. So I talked about roads and bridges, right? And let's see, I can use, I think, let's see, there's an option for me. Oh yeah, I can draw on this. Okay, cool. So you see here, this area here and this area here. This is considered the roadway. And the areas in between these two roadways is the bridge. That might have been obvious to you already. So the most important part I would say maybe one of the most important parts of the projects that we do is defining the roadway alignment, which I have here pointed out clearly, obviously. And think of this alignment as an imaginary line that starts from the beginning of the project and ends at how many ever miles to the end of the project, right? There's a definite start and there's a definite finish to this imaginary line. And it usually, you could say it falls in the center of the road, okay? And this line is flexible. This line is controlled by the engineers, deciding which way it turns and which way it raises and goes down. You can also think of it as a ruler, a really long ruler. We have tick marks that show up in our plan sets that appear along this alignment, kind of like a ruler. So if this was 1 inch, then that would be 2 inch, 2 inch and 3 inch, so on and so forth. But we do that with, you know, say that, and each tick mark represents a station. So this is how we know where we are in the project that we're designing. And then when people go out into the field and construct this project, we say, okay, today we are constructing the project from station 0 to station 500. And how many feet is that? 500 feet. And say the bridge started at station 500, right here, and ended at station 600. It's a 100-foot bridge. And remember how I said that this alignment is flexible? Think about when you're driving on a road. Maybe you go to the countryside. You're driving and driving for quite some time, and all of a sudden you get this really smooth curve, really smooth turn when you're driving. And I love that feeling, and you have like trees around you, and it's just this gradual, peaceful turn that you're making. So the reason why the road is doing that is because an engineer decided that it had to go this way, and it was the safest way possible. And this is governed by horizontal curve calculations that we have to do. And that information is stored in the alignment, either digitally in the computer, or you can do these things by hand. And also, if you think about driving on a hill, going uphill, you feel your car coming up and you come back down. You're like, oh, that was really a smooth transition I had to make, going up and going down again. Well, this is considered the vertical curve calculations that are associated with this alignment. So this alignment controls the geometry of the project, you could say. I hope everybody's with me.
Yes, I was going to say that you can tell when it's not been planned well, because the feeling you get going around too sharp of a curve.
Exactly. Exactly. So now that we kind of have this in mind, the alignment is the highest point at which the project can go. The highest elevation. It decides where the road is going to go, and everything underneath is going to be constructed. That goes for grades and subgrades of the roadway. And same thing for the bridge. And now we're going to go into this bridge. Let's see if I still have control here. Okay, I recreated this image for all of you in a drafting program. And in order to take a look at the insides of this bridge, I'm going to cut into it. All right, so I've never done this before. I've never cut into a bridge like this before, so I'm really nervous, okay? So, all right. Okay, here it goes. Oh, it's getting a little stuck there. Oh, almost. And all right. We cut into this bridge. All right. So this is kind of what the bridge looks like. You know, not every single bridge, but I kind of drew for you what the kind of bridges I work on look like, because that's what I'm familiar with. Okay, and the first part that I want to talk about with this are the drilled shafts. Now, drilled shafts are primarily used in TxDOT projects. And this is the foundation. And the way we create this foundation is by using a type of drilling equipment. So you can imagine this giant corkscrew going into the earth, creating this circle, and we excavate that earth out of the ground. Okay. And then once we have that giant hole, this huge cylinder in the ground, then we place a steel cage into that hole. You can think of it kind of like chicken wire, but a lot sturdier and more up to code. So we put this cage inside of there, and then we pour the concrete. We leave a little bit of that cage sticking up, because next we have the columns. And one thing I'd like to mention about the drilled shafts actually is that these take in ultimately all of the loads from the structure and transfer it into the soil. And likewise with the column, the loads are transferred from the column and then go into the drilled shafts and go into the soil, into the ground. And when I say loads, what loads are you talking about? What are you talking about? You know, what if I were to stand on top of that bridge and like jump around and do things on top of there? Well, the bridge isn't going to fall because the loads are all going to be transferred down. That's considered a live load. And that's the same thing that cars and trucks do on the road. So those are live loads that come in and move the bridge around. And that's why we need the foundation to be strong. So the columns also provide resistance to wind. Say you live in a very windy area. And also if it's located in a place water, like this picture down here at the bottom left, right? This is a kind of a gully of some sort. Perhaps it floods a bit. Columns can provide some resistance to that water flowing. Okay, and next here we have the final part of the substructure. I didn't mention this before, but in the bridge we have different parts that we design. So this cap part, you can call it the cap, it's part of the substructure. And what do you think it does? Oh, it transfers the loads from the superstructure down to the columns, then down to the foundation again. I'm sensing a trend here. Each part of the bridge transfers to another part of the bridge. Okay. And these are, so the cap and the columns are what we see when we drive underneath freeways, right? I think you all recognize this. You all see this part of the structure. I think it's beautiful now when I drive underneath intersections, underneath freeways. I look and I see it all, I understand it. I do all the calculations every day and I just look around kind of in wonder. So hopefully, maybe you will too. Okay, and next we have the girders. And there's all different types of girders you can use to design in a bridge. And actually each state has their own beam shape. These are also beams. Beams and girders are kind of the same exact thing. These beams hold up the deck, but every state has their own standards when it comes to the foundation, the columns, the cap I just showed you, the girders. And they want you to follow that. Don't make it like they do in Washington, only like we do in Texas. And Washington's like, only make it like we do in Washington. Don't go to Texas and look at what they're doing, because that's not how we do it here. And that's reasonable to a certain point. But once you start seeing the differences, it starts getting to be like, okay, this is just a preference that some states have. And some states might freeze and might have to have different concrete standards and things like that you have to follow. But it's very strict. You need to make sure that you're following what the state wants you to do. Okay, so those are the girders, and they come in all kinds of shapes. And here we have the deck. And this is the part that we see, right, when we're driving around, and it enables traffic to cross. It enables you to cross areas that you otherwise wouldn't. Imagine if you didn't have a deck there, if you didn't have a bridge there, you wouldn't be able to get around. So I hope that was painless. And now you know a little bit about bridge anatomy. And if you really liked everything I talked about, or if you thought it was really fascinating and you want to learn more, well, then I guess that just means you're going to have to become a civil engineer. I mean, you're just going to have to switch majors. I don't know. Or you can just watch a bunch of YouTube videos after this. But I don't know. It excites me. It interests me. So hopefully you at least came away with learning just a little bit about it. So once we design the bridge, okay, we do all our calculations. It's not what it looks like, but something like that. Do all our calculations, have to draw the bridge, do 2D drawings of the bridge. This here looks really complicated. It's almost illegible, no idea what's going on here. That's okay. This is a plan view of the bridge at the top. In a plan view, you can call it a bird's eye view. You're looking above the bridge, like pretend you're like floating above it. This is like what it would look like if you had all of the road parts called out to you. That's what these little arrows are called down here, call outs. And you have dimension lines here. These are called dimension lines. So I'm pointing to it, but you can't even see. Okay, these are dimension lines. They start right here, right here. Okay, I won't go into a whole class about understanding drawings, but it's really important. And so we kind of work on the calculations and we work on these drawings at the same exact time, because we have to submit these projects in stages to the state. So we have like a 30% submittal, a 60% submittal, a 90%, and then a 100%. We can't get everything done all at once, so that's why we break it into stages. And since we're breaking it up into stages, then that means there are going to be errors happening, right? Not everything's perfect. I'm not perfect. And when we find these errors in the drawings and in the plan sets, we call them red lines. You can see down below, you see some blue lines. Let's see. Okay, you see some blue lines, right? You also see some red lines. And so these are comments and these are corrections that need to be made to the drawing. And as an EIT, so that's what I am, an EIT, engineer in training, this is one of the best ways that I can get feedback on my work. So the senior engineers look at the drawings that I do of the bridges and they're like, this is all wrong. And I'm like, thank you so much, because I love learning and I love knowing when I'm not understanding something correctly or when I'm displaying something in a way that could be misinterpreted, that could be incorrect. Feedback is a crucial part to growing and learning. And these red lines are one of the big ways that I can learn from my mistakes. And it's great because you're putting together the math with how things are going to be constructed in reality, right? You do all these math in calculations and preparations. Now, how is it actually going to go get built in the field? And the plans are just one small part of that. I think engineers are notorious for not knowing how things are going to go and get built in the field. So you'll need to go and get some field experience for that. But then a pandemic happened and that got sidelined a bit. But I always try to understand everything from every angle, because that's the way you're going to become the best engineer that you can. So this is what I was talking about when I said BIM models and 3D models and roads and bridges. When you do enough of these things and you have a background in 3D modeling, like you studied in school, I showed you before, I studied in school, I made some 3D models. My company recognized that. They saw that I had this background and I had a passion for making models like this. And I have this creativity inside of me that just wants to burst out. So now, on top of my duties as an engineer in training and bridge designer, I also get to work with other engineers across the company. I get to plan out what some of these designs they're making are going to look like. And this is a lot different than making models in school. Okay? There's a lot more that goes into this and a lot more iterations that you have to go through, because these images are eventually going to go to the public. They're going to go to TxDOT. We make these to communicate to the public, communicate to government entities what our construction, what our designs are going to look like. When people hear construction, they just get mad, right? But that's what this image comes from. It's to show people what their neighborhood is going to look like after they complete the project. This project started because there were a lot of trucks waiting in the street, polluting the air, idling, all throughout this neighborhood, trying to get into the port. There's no place for them to park and turn off their cars, turn off their trucks. And that's where this parking lot comes in. And I know, oh, it's just a parking lot, but these kinds of things really make a difference. And that's why I'm really passionate about the work I do. And like I said before, these projects are different than what you're doing in school. So at the bottom left here, you'll see a sketch created by an engineer. This was the sketch I had to go off of. And then I made this. No. Okay, I had to create my first model, show them the next one I did, then the next one, then the next one. They have feedback, they have red lines, they have things they want to change, things that they didn't think of before, like here at the top left. Here are some of what the trucks look like that are being parked in the parking lot. And to the right, you'll see the lighting. They want to have a specific light pole show up there. It was very important to have that. So it's a lot of hard work that goes into these images, and they're so much fun. I love just sitting there and figuring out what's the best way to accomplish this. It's like a big puzzle piece, right? I have all these pieces here, all these inputs, all these engineers around me saying different things, and I have to come in and create an image that is what they desire. And you might be thinking at this point, Karina has her life together. She is, look at her, she's doing all these things and she has no problems in the world, and she's just on point. She's got this going on. And the truth is, yeah, maybe a little bit, but one thing I recognize is that people say it takes a village to raise a child. But one thing I say is that it takes a village to keep a woman in STEM. I have a support system. I have people who believe in me when I don't believe in myself, because there are times for that. I'm not always confident in myself. We all kind of go through these things, whether you're a man or a woman, honestly, if you think about it. And I had a lot of people along the way to help me out, but that's because I reached out. And I'm continuing to reach out, even in my professional life. So here are some of the people that have helped me along the way. As I told you, I'm a part of the Society of Women Engineers, Houston area chapter. So we have, I believe we still have a chapter at UHD, but you can continue from there and join the professional chapters. And so I spent all of the pandemic talking and spending time with all these other women stuck at home as engineers. And these are people that I could relate to and I can talk to. And I know that I have, we call each other sweesters. That's really cheesy, but we're sweesters. And we help each other. And I don't feel alone. And I have my cats and my dog. And I have professors in the past who have been there for me, who have encouraged me. And so you can't do these things alone. And you can't depend on just one person in your life to provide support for you. I know a lot of people say you have to support, your family has to support you, but that's not always the case. Family might not always be there for you, but there are resources and places you can turn to and people you can talk to. That's why Scholars Academy is so awesome. I remember all the conversations I had with Miss Nakamura, just, it's just things like that happening over and over again. It keeps you grounded. It keeps you where you need to be. And also with SWE, I don't know if you can see in the top left of this image is me. I DJ all the parties now, or all the events that we have as DJ Space Bunny. And it's another outlet for me to like be silly and be myself. And I have people who accept me for who I am. And I really love that. And I would like to end with sharing some resources with you. There's the Great Minds in STEM MentorNet, which I actually was a part of while I was at UHD. I kind of took the initiative and signed up for that. And I got paired with a really amazing woman. And it doesn't matter your gender or anything, everybody is qualified to do this. And you see I have a QR code here. Just use your phone really quick. You can click on these links, check them out. The SWE Mentor Network, you can sign up to be a mentee for that, but you do have to be a SWE member. And I know there's a lot of women that I talk to all the time in our chapter who are mentors for this. So it's a great organization. I'm actually proud to announce that I will be a part of the executive council for the upcoming fiscal year. I'm going to be the secretary. Thank you, Dr. Parker. And it's just it's given me a chance to be a leader and practice leadership skills. So it's a great organization. And I'd like to thank you all for listening to me. And I hope you all learned something today. Thank you.
Oh, wonderful. Let me ask, do we have any questions? Anyone?
Yes, I have a.
I'm sorry, go ahead.
Okay.
Yeah. So, you know how there's a lot of math to it? Like for people that are not really good at math, do you think they could still do something like engineering?
Do something in engineering, you mean?
Yeah, like since you're familiar with engineering,
Yeah, so the way you combat math inadequacy, or as I like to say, perceived math inadequacy, is that you have to practice.
Yes.
It's a skill, and you have to put in 5 times as much work as the people around you, and it's going to suck. But once you learn the rules of math, you start to see how beautiful it is, and it becomes natural to you after a certain point. So you can become an engineer even if you're bad at math. You just have to work really hard to it and keep your goal, in front of you while you're doing it. So that would be my response to that.
Yeah, that's a great answer, I think, because many of us grew up with feeling we couldn't accomplish in math, and yet I see people from high school to college do great things with their math, and they weren't great before. So it's a matter of learning the skill sets that will move that career forward for you. And I think that's a wonderful answer you gave and a very good question. Now, somebody else had a question. Let's see.
Yes, I have a question. So, from what I heard from this presentation, it seems like in your job there's no room for mistakes. So, are you always in a fear that you have to do everything perfect? And also, is there any consequences if there is a mistake, like regarding to your license or to your professional work?
Oh, that's a really great question. So I am terrified every day, or at least I started out that way. I was probably really annoying to everybody around me, and I didn't care. Because if I wasn't annoying and asking questions and asking people to check things, even if they didn't have time to do it, because I did that because I didn't want to make any mistakes, and I wanted to make sure that people around me were training me and teaching me the way things needed to be done. So at first I was really scared, but I think because I was so annoying and so persistent and so determined to do a good job every time, learn the right way first if I'm ever confused about something, no matter how small. Took a lot of notes.
Mm-hmm.
Because I did that, I think I've gotten to a really good point to where I have more confidence in myself when it comes to doing these things. And I kind of shook off the nervousness about asking questions. And to the other part of your question, how do mistakes affect you in the workplace and your license? Well, I'm an EIT, which means my license doesn't hold any power until I become a PE. I have to gain enough experience. So the PEs around me take the blame if I mess up. But because I'm so persistent, I'm very careful, there's a lot of trust in me to do the work. And so no one's worried that I'm gonna mess up. I think I worry the most. It's amazing how much confidence my supervisor has in me, honestly. But maybe I'm not being fair to myself.
Well, I think too, as you get the reason the PE takes so much experience, and then you sit for the license test, right?
Mm-hmm.
So it's like being a doctor. You know what you need to know, and but you're still learning. But it's learning the statutes and learning the critical dimensions, the weights, the whatever, the boundaries when you're getting ready to draw for the bridge that you're going to draw or whatever. It's, all of that comes with experience. And didn't you do research before your internship, or did you just do the internship the whole time you were with us?
No, I didn't really do any research, and the internship I did wasn't exactly related to engineering. It was more like project management.
Oh, yeah. Well, but that still plays a role, I think.
I learned a lot about surveying, and I got to sit with engineers who would come to the Port of Houston and ask them questions about what they're constructing. So that was really good insight. But yeah, the engineers that I work with have been doing this for years. And I'm surprised by how they just look at something and immediately just see like what's wrong with it.
Right.
I'm like, how do you do that? But it's true. It's with experience.
Well, and there's a recent incident on 288. They just finished building a section of the road, and within weeks it has collapsed.
Yes. Mm-hmm.
So you can do I think about also 9/11 and these skyscrapers, and they were very sturdy, wind-wise and structurally. And then you throw a 750 or however big the plane was loaded with fuel. It doesn't matter what you did right or wrong, that thing was going to come down anyway. But something happened with the 288. So I'm interested in finding out about that. But you will have errors, but you have levels of this is going to be approved, this is going to be approved, this is going to be approved. And so you have multiple sets of eyes through the journey of building it.
We have it's called a QA/QC process, and it's something that I'm helping to develop too in my company for design calculations and how to use our workbooks. Like we have these really complex Excel worksheets that help simplify the calculations that we do, but all of that has to be vetted through quality analysis, quality control, QA/QC.
Excellent. Any other questions? Anybody? Those were good questions.
I have one question.
Okay.
Thank you so much. The presentation was really amazing. What makes you excited about the future of engineering?
Yeah. Okay. So what makes me so excited about the future is that so the company that I joined it because I looked on at the executive page of my company, and I saw that there were people of color and that there were several women who were making the big decisions in the company. And I'm starting to see that more and more in civil engineering, but it's not happening, in my opinion, at the rate that it should. So I look forward to seeing this happening more. And when these things happen, innovation occurs and good changes happen, like the adoption of new technologies and being open and receptive to all these different ideas. Remember how I talked about BIM before? Well, I'm actually a part of a group that's trying to put together a budget proposal to invest more in this software and this technology, because it will help us plan for these projects. We can take surveys taken by drones and look at what the land is doing, how it dips,
Wonderful.
what problems might happen. Another thing you can do with the models is, it's already actually kind of happening, but you can program grading machines. And when I say grading, you could think of like kind of a steamroller or a concrete pouring kind of machine. You can program it using this model and automate the machine, and it will automatically go and lay the road how you need it perfectly. And so we have all these, and 3D printing as well. 3D printing is happening. We have prefabrication going on. When I say prefabrication, I mean you can create part of the bridge ahead of time. So let's say those columns, well, no, not the columns, but the bent cap, and maybe the columns and the beams, you can make those all in like 3 different factories, okay? You don't have to make them on the site. And then trucks come and they bring them onto the site, and you can build structures within weeks instead of months, and that saves time and it saves money. And I want to be a part of all of that. I'm excited to be a part of all of that. So yeah.
Wonderful. Any other questions?
Hi, it's me again. So I want to piggyback to the question that I think her name is Joanna. I do want to go back to that because I have that fear. I'm scared to make my first mistake, and even more, making my 5th mistake, because I don't know if all senior engineers are patient or understanding. I don't know. And so I'm actually scared to the point that they would discourage me to even continue on, to the point that It will make me feel like, oh, what have I been doing? Like all those years in school, like I'm just scared to get to that point. So I guess my question is, for both of you, did you ever feel discouraged in a workplace? And if so, what did you do to overcome it?
Yeah, that's a good one. Well, I think a lot of my feelings of discouragement actually come from myself. I'm fortunate to work with people who are extremely patient with me. And I thought they were annoyed with me and are done with me, but they tell me that in the end, they actually really value what I bring to the table and what good work that I've been doing. So they've told me that I'm appreciated and I've caught mistakes. And if you make a mistake, that's expected. There's no way that you can know everything when you first show up. And so I made mistakes too, but they're like, oh, it's no big deal. And I think I'd like to think that a lot of engineers are like that, no matter if you're a woman or a man, and they know now you can't do that. You can't be mean to people. And I'd like to think the culture is changing.
Yes.
And I don't know if this might help you, but the very first woman who received her professional engineering license in America is from Texas. I think she got it in the 40s or the 50s. And I read all these articles that were written about her from such a long time ago. And she said that the men around her were even encouraging her back then. And I know maybe because it's being published, so she said that. But they wrote about her life, and her life is amazing. She worked on Highway 6,
Wow.
actually, or something like that. And I was like, wow, that's right here. And I don't know, maybe in Texas, civil engineering is like been here forever. And I think you'd be surprised to find the amount of women that are working in the offices. There aren't a lot of women in structural engineering, I'll tell you that. But where I'm working, there are a lot of other women in the other departments. And I think the men want women to be there. And I know that's good that I'm there because I kind of like brighten things up. And I like to think I also bring that. And so don't be afraid. Really don't.
Okay.
And if someone's mean to you, you let me know.
I will.
Because I
will.
will help you out. You message me, you text me. I don't know if you have my number, but
I
anybody
still
here,
do.
add me on LinkedIn, send me messages, and tell me what's going on. I'm here for everybody who needs help. And Scholars Academy is there for you too.
Okay.
Yeah, I think great advice. And I think, I just want to reemphasize, she made a fit for what she saw was important and valuable before she joined that company. She wanted diversity and she wanted women at the top, and she found that. And everybody has fear of the first job, but the more experience you can get with an internship or research, you're better off. And you have to do your due diligence before you say yes to the job. You can put out 100 or 25 applications. You check to see the organization. Is that what you want to join? And then you stay for a year. If you join it, you stay for a year. And if it's not a good fit, then you begin to move on. Don't quit quickly, because then you look like a job hopper, right? You want to be able to stay a year. 2 is better, but sometimes you can't tolerate 2, and go find another company. And now you have some experience. So I want to end there, and I don't want to be the last one to speak. Let's give Karina a wonderful applause. She did a great job. Good information.
Thank you, Karina.
Oh,
Yes.
thank you.
And, you know, we wish you all the best as you continue down your career in civil engineering. You know, it's going to be exciting. It's already exciting. And I think all of you need to think about joining SWE. You contact Dr. Waining Fang, and she knows about it. She's the sponsor of that program. All right. Karina, thank you so much. We appreciate it.
Thank you so much for having me. And I wish the best of luck to all of you for the rest of this semester.
Okay, great. We'll see you all next fall. We already have 3 lined up, and we'll be putting those in the weekly in the summer. All right. Thank you so much. You want to unshare?
Oh, yes.
And then, yeah, wonderful. All right, you all. Have a great weekend and a safe one. Get your vaccinations. All of you, get your vaccinations.
Thank you so much. Have a good weekend.
All right. Bye-bye.
Bye-bye.